History has known many great liars. Copernicus, Goebbels, St. Ralph the liar. But there have been none quite so vile as the...
Hello, Hambini fans!
Hello everyone, Reginald Scott here. Welcome to the video. Great to see you all again, and I hope you're all doing really well today. You may not know that Hambini and I don't get on very well. We have a long-standing feud. So if you want to catch up to speed on everything that kind of happened thus far, the best video to check out is this one, Hambini Fact Checked. This is actually the follow-up video to Hambini's response to me, in which he told a whole string of lies about me and my tools. So he came back with this video, Hopeless Biomechanic Highlights Incompetence in Own Videos and Engineering Reaming. Hello everyone, it's me from the future. So I was in the process of editing together this video, and what I wanted to do for this project was debunk every single lie that Hambini told in his video. The problem is that Hambini is such a compulsive liar, which you will see in this video, that he tells so many lies that the runtime would be like an hour and a half. It's already an hour, and I haven't even finished yet. So what I'm going to have to do is cut today's video down to just the most important technical lies that he told. So that is lies about engineering and mechanic work that he told. And save all the other stuff for a separate video. So if you want to see that compilation, do let me know in the comments below, and I will endeavour to edit that one together in a separate video. Right, thank you for watching, and let's get back to the video.
Here we go. This is him with a vernier. I don't know if that's from Aldi or Amazon. Who knows? But you know what we're like with verniers on this show.
So Hambini is criticising me for using a vernier caliper to measure the internal diameter of my bottom bracket. Now, I don't have a better tool to do this job. I admit, if I was a real engineer, I wouldn't be using a vernier caliper. I would be using the correct tool to measure the diameter of a bottom bracket. So here is a video of Hambini using a vernier caliper to measure a bottom bracket.
In the shot, oh god, there we go. That is around 40.89, and if I press really hard, 40.9.
So Hambini is pressing the sharp jaws of a vernier caliper into a soft carbon fibre bottom bracket to get an accurate measurement. I, on the other hand, am pressing the sharp jaws of a vernier caliper into a titanium bottom bracket shell, which will not deform or cut in any way. Not the case with a carbon fibre bottom bracket. But as we can see, this engineer, who doesn't like me using a vernier caliper to measure my bottom bracket, is yet again using a vernier caliper to measure a bottom bracket, when he has better tools to do the job. So I don't have better tools, that's why I use the vernier. Hambini does have better tools, but he doesn't use them. Okay, so this is the stage of the video where Hambini criticizes the accuracy of my bottom bracket in my Lightspeed titanium frame, and many of his fans sent me comments suggesting that the bottom bracket was massively out of spec. Is that true, or is it an exaggeration? Let's find out.
So he's got a titanium bottom bracket and he's measuring it.
About 45, 91, 92. I'm getting 45, 92. So you can see that it's pretty consistent.
Consistently shit.
You sure about that?
We'll come on to this bit in a minute.
And what's nice about this is because it's so perfectly aligned.
What I can't believe there is, he has gone to say that the bottom bracket is perfectly aligned without actually doing an alignment check. So it's round, he's measured it as a round, but it's fucking undersized, man. That is seriously undersized.
You sure about that?
The limit value is 45.95 to 46, and he...
You sure about that?
On titanium, and titanium is absolutely unforgiving. On titanium, you want to be up like 45.99.
You sure about that?
Something like that, 45.98 at a push. You really need to do that.
You sure about that? First thing I want to talk about is the fact he mentioned that the bottom bracket is indeed round. He said it's round, it's measuring as round, and that is correct. The bottom bracket is indeed round.
It's round, he's measured it as a round.
So the hole is round, That's good, and that already makes it way better than your average bottom bracket on the market. Now, he says, I didn't do an alignment check, so I can't claim that the bottom bracket is aligned. And I know from my experience with this bottom bracket shell that it is indeed nicely aligned. And I know that for 4 reasons. Okay, reason number 1, my spindle. So I have an aluminium spindle on my bike. It's a SRAM spindle. And if you have an alignment issue, the spindle will wear unevenly. Okay, my spindle is currently wearing very nicely, thank you. It's very consistent all the way around. So I don't have any uneven wear on my spindle. The second way that I know is because of the manufacturing process of Lightspeed. Let's go look at that. So first, they weld the frame, and then they machine out the bottom bracket. Okay, so welding comes first. If there's any distortion in the welding, which there shouldn't be, because Lightspeed know what they're doing, and NASA trusts them to make titanium things, so I think I will go with NASA on this one, rather than Hambini, the shop. So even if there was some distortion in the tube, it would get machined out, because the bike is in a jig, and they're machining through the bottom bracket shell, and it will be consistent all the way through. So even if there was a high or low spot as a result of the welding process, that is now gone because they are machining out the bottom bracket. The spindle I'm using is a 30mm SRAM red spindle. The tolerance on that spindle is extremely fine. They are notoriously difficult to get through a lot of bike frames, because a lot of bike frames do have alignment issues. But if you can't get it to poke through the other end easily, like you have to put it in the freezer, or you have to hit it with a mallet to get it to go through, that's a good indication that there's an alignment issue. However, if you can push the spindle through without really any trouble, then that's a good indication there's no alignment issue, because it goes in there, pushes straight through, no issue whatsoever. The final piece of evidence I will give you is the spin test, and this is bog standard steel bearings, like normal seals, like these are not special low friction seals or anything, normal grease. This is as basic as you can get. Like, even if I spin it on my fingers, it just doesn't spin, because there's so much resistance in the grease in this bottom bracket. If you've got a bottom bracket that's misaligned, what will happen is when you spin the crank, it will start off spinning, it will slow down very quickly, and it will come to a dead stop. Like, it will abruptly stop like that. What you want it to do is to gradually slow down against the grease. Okay, so if you've got a gradual deceleration when you spin it, it doesn't really matter how long it spins for, because again, that's very dependent on the quality of the bearings and the grease. But if you spin it and it's a gradual slow down to a stop rather than a dead stop, that's a good indication that everything's fine. If it dead stops, that's bad. That means usually you've got an alignment issue because the bearings are struggling to rotate. Let's have a look at what mine does. It spins fairly nicely, and it's starting to slow down. It's slowing down, it's slowing down, it's slowing down, and it comes to a gentle stop. There is no abrupt stop there. A cheap bearing, that's spinning very well. That is how I know my bearings are aligned. Okay, so his next major accusation against my bottom bracket is because it's measuring at 45.92, that is atrocious, terrible, shit. A lot of Hambini catamites wrote in my comments on that video that my bottom bracket was massively out of spec. Okay. Part Tools is like the main manufacturer of bike tools in the world. All bike mechanics use pretty much Part Tools at some stage in their life. They say that the hole in your bottom bracket shell should be about 45.94 millimeters before you fit your bottom bracket. Now mine is 45.92, so I am 0.02 of a millimeter away from the perfect standard, which is 45.94. Hambini suggests that the bottom bracket should be, in general, 45.95, which he actually went further and said it should be 45.99, which in comparison with the Part Tool standard is way too big. That's almost 46 millimeters. The bottom bracket itself is supposed to be 46. And the reason why the bottom bracket shell needs to be slightly smaller in order to fit the 46mm bottom bracket is you need an interference fit. So you need a little bit of pressure around the cups to hold the cups in place. It needs to be tight in order to work. So I am closer, straight from the Lightspeed factory, to the standard set by Part Tools than Hambini is suggesting I need to be. That it should be 46mm. But that's what you call a nominal value. What's a nominal value? So listen to this.
So the nominal dimensions are as follows. It's about...
He says the nominal dimensions. What does he mean by nominal? Nominal is existing in name only. So to describe it in a way that maybe is going to be easier for you to understand, if you've got a car and on the back of the car it says 1.6, you know, Vauxhall Astra 1.6, and that means that the engine is 1.6 litres, right? But is it actually 1.6 litres? No, that's just the nominal, the name sizing of the engine. So here on my vehicle registration form, we have the nominal sizing of my Pajero's engine. On the back of the vehicle, it says 2.8 litre. But in reality, when the vehicle's been tested, it actually came out at 2.835. Now, they don't stick on the back of the vehicle 2.835, but in reality, that's what it is. This is the difference between nominal value and real world values. So the nominal value on this box is 46mm, but this actually 46mm? This is a Paraxis bottom bracket, and if you go check the Hambini website, Hambini says that this bottom bracket is basically as fast as his. He said that there's so little difference between this bottom bracket, it's less than 0.4 of a watt or something difference. So this is a really well made, well engineered bottom bracket, and this one from Paraxis is coming out at 45.95. So this bottom bracket is not 46. This is a full 0.05 of a millimeter different in size from the standard written on the box. Okay, so it's a 46mm PF30. That's what it's supposed to be. All right, let's try a different brand of bottom bracket. This is the BBB one that I have, and this BBB one is 45.97. So this is 0.03 of a millimeter different from the sizing that supposedly it should be, which is 46mm. It's still a little bit undersized. So my bottom bracket being undersized by 0.02 of a millimeter is not that bad, because this is out by 0.3. So the fit between this bottom bracket, e.g. the one I actually use, and my frame is near enough perfect. All right, let's go again. One more brand of bottom bracket. Now this is a funny one. This is a SRAM bottom bracket. This is the bottom bracket that technically I should be using in my frame because I use a SRAM crank. And this one is coming out at 45.93. So again, what we see is here, we've got 3 different brands of mass market bottom brackets. In comparison with my bike frame, they work exceedingly well, because my bike frame is only undersized by, according to Part Tools, 0.02 of a millimeter. Now here's the thing, you might not fully understand the kind of sizes we're talking about here, so let me demonstrate that to you. We have the thickness of a human hair. I have here on this piece of white foam, hopefully you can see it, I have a human hair. This is actually one of my human hairs. So there you go, about 0.05, 0.06. Now we have some context. My bottom bracket, in reality, is out by 0.02 of a millimeter, which is less than half the width of a human hair, because 0.02 of a millimeter is tiny. It is smaller than this. It's less than half the size of this. So what is Hambini doing? Hambini is lying to you. He's telling you that my bottom bracket is massively undersized. It's not. It's almost perfect. And he's also telling you that in order for it to be correct, it needs to be way bigger. Now, why is Hambini saying that? Now, so this is Hambini fitting a PF30 bottom bracket to a carbon frame. Now what he's done is he's just sanded out the carbon frame, and now he's going to check it with his standard, what he believes is the standard for fitting bottom brackets to frames. Now, bearing in mind, he is fitting one of his bottom brackets to this frame, not one from the mass market like the one I use or the one you probably use.
And check it, so 45.96.
Right, so he says 45.96, but the gauge that he's using there is actually a 45.98, and this is fitting into the frame. So his standard, Hambini's standard for his bottom brackets, is much bigger than that of Part Tools. And the reason why his standard is much, much bigger than everybody else's standard is because his bottom brackets are bigger than everybody else's. Like I've just shown you, the majority on the market are under 46mm. If you go measure your bottom bracket now, if it's not a Hambini bottom bracket, it will not be exactly 46. It will be less than 46. Whereas Hambini bottom brackets are exactly 46mm. And that is the reason why Hambini bottom brackets constantly get stuck in frames. So this video is fairly common on Hambini's page. And what it is a video of a Hambini bottom bracket stuck in a frame. This happens a lot because, but here we are, somebody's tried to push in a Hambini bottom bracket in their local bike shop and it's ended up getting stuck in the frame. That Hambini is assessing the whole world, or the whole bike industry, on his standard, which is an aerospace standard. The whole bicycle industry isn't an aerospace industry. They're bicycles. They're not jet fighters. You know, if you've got a discrepancy of 0.02 in a jet engine, it's probably serious. But in a bicycle, it's not that bad, unless somebody making an aerospace grade part that needs aerospace grade tolerances comes along, and that's when it becomes a problem. So this is me pressing in my bottom bracket to my frame. You can see I'm only using 1 or 2 fingers to rotate it. See, look, it's just 1 finger I'm using. I'm holding one side and I'm using 1 finger to drive in this bottom bracket. Now, if my bottom bracket was massively undersized, I would be seriously struggling to get that to go in there. But I'm not. It's easy because the sizing is just about right. Let's watch Hambini do the same thing on his bike. So this is Hambini's carbon bike. He's pressing in a Hambini bottom bracket. This demonstrates how much tighter a Hambini bottom bracket is in comparison with mine, and how much harder and more pressure is exerted on the frame.
Okay, that is home now.
It sure is. Did you hear that? Not only is he using his full fists to crank that thing down because he's got so much resistance working against him putting that thing in the frame, but you can hear the frame complaining. That clack, clack, clack is the friction building up to a point where it has to break, and that's the bottom bracket being jolted into the frame under extreme pressure. So again, Hambini's criticising my bottom bracket for being undersized. We can clearly see that even though Hambini's standard is bigger than the actual standard for bicycle bottom brackets, he is meeting much more resistance to get his bottom bracket in a frame.
This he loves his titanium bike. He goes on about it being the best thing since sliced bread, but have a look at that. You can see the shell near the top is quite thin. Where the cursor is, hopefully you can see that. If not, zoom in. And then at the bottom, it's quite thick and it's quite irregular. So it's well.
What you just said is one of the most insanely idiotic things I have ever heard. Everyone in this room is now dumber for having listened to it.
His argument here is because this wall thickness here appears to be thicker than this wall thickness here, that is an indication of poor engineering or poor quality. If we go look at some carbon bikes here, what you will notice is that the bottom bracket shell area has got something called variable wall thickness. Some sections are thicker and some sections are thinner. All right. See, the easiest way to make a bottom bracket shell in titanium would be to take a straight gauge round titanium tube like this that's round on the outside and round on the inside and is straight all the way through, and just weld this to some other tubes. That would be the easiest way to do it. Lightspeed are the best titanium bike makers in the world. They don't do it the easy way. This frame here is another frame that I have. This is a Lightspeed T2. This is the same type of bottom bracket that's on my T1 SL. And what I've done is I measured the wall thickness here on this side and the wall thickness here on this side. This one's coming out around 1.4 and this one's coming around about 1.8, something like that. So there is indeed a difference in the wall thickness at the bottom here than at the top. What you'll notice about the top is that there are other tubes welded to it. So it has support and strength from the welds around here and from the other tubes supporting it. But the underside here is just hanging in free air. So that needs to be reinforced in order to maintain the stiffness of the bottom bracket. But you don't need that material up here because you've already got the reinforcement from the other tubes. And so what Lightspeed have done is they've reduced it to make it lighter. It's the same reason why they put a step here and why they put a step internally here. It is to reduce weight where they don't need it. They could have left the whole bottom bracket tube 3mm thick all the way through, but they didn't. And the fact that it's got variable wall thicknesses is an indication that this is a very, very well engineered bottom bracket. And how do I know this is not a mistake? Well, number one, it's the same on this bike as it is on mine. Okay, the measurements are identical. That doesn't usually happen by mistake. The second thing is, we know the center is perfectly round because Hambini himself admitted it's round and I measured it as round, and that's the thing that needs to be round. The exterior doesn't need to be round. So for Hambini, an engineer who should know about these concepts of variable wall thicknesses and reducing weight where it's not needed, thinks that because the wall thicknesses are different, that somehow indicates a bad frame or a bad bike. Okay, so here is another example during the video of Hambini lying to his audience again, and he lies with such frequency and ease, he'd have probably made a better politician than he does an engineer. Let's have a listen to Hambini lying again.
So he's measured a bottom bracket there, and it is undersized, so the hole size has got to be 46mm.
Why the fuck you lying? Why you always lying?
The hole size has got to be 46mm, and his bottom bracket is measuring 45.97. What is scandalous?
What is scandalous is the rapidity at which Hambini lies. So he just stated there something which we know to be blatantly false. He said the hole size, e.g. the hole size in the frame, needs to be 46mm. That's not true. The part tool standard, which is 45.94. Okay, so less than 46. His standard for his much larger bottom bracket, which is a little bit over 46mm in size by a few microns, is 45.98. So him making the statement that the hole in my frame should be 46mm is blatantly false, and it's blatantly a lie. What's funny to me is this bottom bracket is so close to 46mm for a bicycle standard, and we're not talking aerospace here, we're talking bicycle standard. It's 45.9, which is pretty bloody close to 46, and it's 45.97, so it's almost bang on 46. It's only 0.03 of a millimeter, like the half the width of a human hair, away from being exactly 46.
Right, so now he's going to talk about the BBB bottom bracket.
Again, it's got, again, very nice quality bearings in it at the top.
This is the bit that it's just a fucking lie, man, right?
Keep telling yourself that, darling.
Self-aligning chrome alloy steel bearings, okay? That there is no way the bearings in there are self-aligning steel. What's happened here is Reginald has read directly from the spec sheet for BBB, and BBB said there. So it says self-aligning bearings increase durability. I can tell you for a fact that this bottom bracket does not have self-aligning bearings. So this is what a self-aligning ball bearing looks like. You can see the two rows of balls, and it's got a spherical motion. That is not self-aligning. You can't have a self-aligning bearing with a seal on it.
You sure about that?
can't have a self-aligning bearing with a seal on it.
You sure about that?
Look, it's got to be plain because the seal will just, rip out. So it's just basically bullshit.
You sure about that? Here's the thing, he just states that a self-aligning bearing can't have a seal on it. Well, there's a picture here, right here on his screen, and here's another one over here with 2 balls on it, and these 2 have seals. So this one has a seal, and this one has a seal. Technically correct that the bearings in that bottom bracket are not individually self-aligning bearings, but as a bearing unit, it is self-aligning. So I went and asked BBB for them to clarify what they were talking about on the spec sheet. So this is the email I got back from BBB. Great technical question. I understand the confusion and you are right. Indeed, the bearings itself are not self-aligning bearings. These are generally not durable, available or applicable in most bicycle bottom bracket scenarios. I think the feature has been shortened since the original text was written, so BBB are a Dutch company. Perhaps it was written in Dutch and then poorly translated to English. It is supposed to say self-aligning bearings due to the 3-piece threaded design. As the featured text above describes, it's the design that makes the bearings self-aligning compared to traditional BB8692 designs. They are indeed self-aligning because of the design of the bottom bracket, which is a threaded type. Okay, so when you screw it in, it lines up. Hence why they call it self-aligning. The bearings themselves are not self-aligning, but the entire bearing unit is. So
earlier on this year, we had something called blind bearing puller gate, which was where Reginald made a video which a lot of people actually follow the instructions on here, and I'll be honest, some people
Hambini, being honest, if that day ever comes, I will eat my hat. This bearing puller thing has been going on a long time now. I've already proved him wrong twice in 2 of the videos. So this is the video I recommend you go watch if you want to know all about the lies he told in the previous video. But here it is again. Next, Hambini represents the bearing puller going inside the preload tube. This in reality never happens because the legs of the bearing puller are sprung loaded, and once they reach the recess behind the bearing, which is the chamfer and or radius, they snap into position above the preload tube. Interfaces with the bearing flush like this, so that the tube that comes out in the middle, as you can see, the puller doesn't go inside the tube. The puller sits inside the bearing, flush, behind the tube. So the tube doesn't come in contact with the teeth of the puller. The drawing that Hambini made is false. It doesn't exist in reality. See, from my practical demonstration, he is lying. The bearing puller jaws do not go inside the preload tube, so there's no possibility at all of the preload tube getting damaged from the puller. It is false. It is a lie, and I can't believe he's still telling the same lie after all this time.
Now, for this video, you can see my bike is well used and well thrashed. Now, I'll stick my hand up and say I don't take care of the bike whatsoever. So all the pedantic people who say you shouldn't use a screwdriver and you shouldn't do prying and all that kind of stuff, those comments are totally valid if you care about the paint. If you don't.
Right, so in that case, don't make maintenance videos. If you don't care about your bike, don't make a maintenance video showing a total disregard for care for your bike. Because people who think you know what you're doing, Hambini, are going to watch that, and then they're going to show the same disregard to their bike and potentially damage something. Okay? So, why are you setting a bad example? Come on. Are we back to this again? Yeah, we're back to this, which is hammering. You know, whacking away at a carbon steerer with a massively comically oversized mallet. The frame is clamped via the top tube in the bike holder. So he's wailing on the bike frame with a massive mallet, and the frame is clamped by the top tube. Unreal levels of ineptitude when it comes to bike maintenance. Here we go. He's still going. That's bottomed out. That's bottomed out. Stop hitting it.
Oh, brother, this guy stinks!
You can see this top cap here. He thinks it's coming out as one piece because it's full of corrosion. Now, I don't expect any mechanic to know that it's threaded.
This is interesting. That bolt and that top cap there, I'm guessing the top cap's made of aluminium, is totally bonded together. You can see that they're moving in unison. That shouldn't be the case.
There's a picture later on, so you can see this is, it's got a collar on it, so it's threaded.
You're lying so much.
Why? It's got a collar on it, so it's threaded.
So the lie that Hambini is telling here is that this top cap on his bike is unique, and it is in fact threaded together. And so his evidence is that there's a lump here at the back of the top cap. Bunch of top caps here. We got this one from Cane Creek. As you can see, it is not threaded on the inside, and it has a lump at the back of it. Okay, so in order for it to have a recess there to hold the bolt head, it needs to be machined like this at the base. Ginelli, this is another aluminium top cap, very common design, and again, there is a lump at the back. This again enables you to put a bolt in it and it be flush with the top of the top cap.
I'll just play this. You can hear that creaking round, and that is because it is at a high diameter. So you've got an M5 screw and a large top cap, like 30mm, something like that. So as it goes round, the force is on the periphery, and when you...
So what he's explaining here is true if that top cap was indeed threaded into the bolt, or the bolt was threaded into the top cap. Now, if you did have a top cap that was threaded so that the bolt was threaded in and solid and in position, and then you did try and tighten it down on your headset, you would get that problem. You would get that creaking sound because of exactly the principles he's explaining. But that is why these top caps are not threaded. That's why the bolt is independent and it's able to rotate. Some of them even come with a little washer inside to help the bolt rotate, because what you want to do is you want to fix the top cap in position and then tighten the bolt without the top cap moving. This brand here, ITM, it's an Italian brand. Now, Italians are all about style and looks. There is no way an Italian company would design a threaded top cap that you couldn't align properly when you're screwing it down. Okay, so these are the standard ITM compression plugs and top caps that they have. This one here I have is from BBB, but they're, as you can see, essentially the same thing. Very common. We see hundreds of these, thousands of these a year working as a bike mechanic. There we go. This one has got a screw. It's got a washer to help the screw rotate so it doesn't damage the top cap. It's got a top cap. It's got exactly the same kind of lump sticking out the back of it as the one Hambini shows us. Let's zoom in a little bit. Let's keep zooming in. There is no threads on the inside of that top cap. It is a smooth surface because, again, it needs to be able to rotate so that you can tighten it against the top of the steerer tube. So these are your like traditional ones, as I say, with the bolt and the standard top cap, just like the one Hambini has got. Yeah, here's another one. This thing here, from Cannondale, believe it was made by FSA. It was a special top cap, only produced for Cannondale headsets, as you can see, and it is quite unique. In fact, this is like this. This is a threaded top cap, and as you can see, the compression plug is very narrow. It has a very short body to it, unlike the standard compression plug that Hambini has, and it has a very fat core to it, and on top of that core is some threading, and that is what you thread your top cap onto. Now, your top cap, however, does not look like a normal top cap. It has a very, very thin body to it, okay, or the top part of it is extremely thin, thinner than this, basically, and it has a very chunky and large diameter section here for threading on the top. They made them in a few different styles, but essentially they all look the same. They were a short compression plug. They were not particularly safe, to be honest with you. short compression plug and then this very unusual top cap. So here's the rub. We know that it's stuck in there because of corrosion, because we can see that corrosion. So this is Hambini talking this thing up. Ooh, right, did you see that? You can see here there is a white powder. There we go. Can you see these little white fragments popping out of the headset? There's one here and two here. These little white crystals, that is aluminium oxide, and that is the corrosion which is built up in that top cap, flying out of the top cap as he over tightens it. There's some more of it. There's lots more of it. Look at it all coming out. All these white crystals, all this white chunk coming out. It's got more crystals than Breaking Bad.
Ah, tight, yeah!
And that is all aluminium oxide corrosion. Hambini is about to tell you his final lie. Oh, by the way, watch his chair bouncing around all over the place. It's nerves. He's really nervous at this stage. You check his chair. His legs under the table are going like the clappers.
What I've shown you is, frankly, it's borderline shocking, really. I mean, trying to confuse a threaded joint with a corrosion of stainless steel and aluminium. I've never heard anything like it before in my life. Never seen anything like it.
Stop fucking lying.
Right, so the headline is, an aerospace engineer has never, supposed aerospace engineer, has never heard of corrosion between stainless steel and aluminium. Is that the lie you want to tell, Hambini? Because we can Google this right now. Let's Google it. So the first page we're going to look at is this. The combination of aluminium and stainless steel causes galvanic corrosion. Will aluminium corrode with stainless steel? Stainless steel is reactive with aluminium, and when stainless steel screw is in contact with an aluminium base metal, the aluminium is likely to corrode. It is well known that bringing two metals into contact can cause corrosion. Corrosion develops when two dissimilar metals are combined in a corrosive electrolyte, hence like your sweat that you drip on your headset every time you go for a ride. This can occur when certain metals, such as aluminium, are in contact with stainless steel. So an aerospace engineer just said he has never heard of stainless steel and aluminium corroding together.
Corrosion of stainless steel and aluminium. I've never heard anything like it before in my life. Never seen anything like it.
God damn it! You can't make this shit up!
There you go, folks. That concludes me reviewing this vile and slanderous video. If you do wish to remain subscribed to Hambini, good luck. And as always, folks, stay safe when you're out riding on the road, and I shall see you in the next video. Bye-bye.